All right, section 9.8, let's jump into compound inequalities and see what those have. So see what happens there. Find the union and the intersection of two sets, graph the compound inequalities on a real number line, solve the compound inequalities containing and, solve the compound inequalities containing or. Okay, the union symbolizes U, as in A union B of two or more sets of the union sets elements that belong to either one or set or the other. Okay, union. Let me just kind of draw this out here. Okay, I'll just kind of draw two little quick circles up here. Okay, I've got a circle here, and I have a circle here. Okay, notice in union symbolized as the U symbol, okay, is a set of all elements. So if I've got a set, say here A, and a set B, notice in here, I can come here and go, okay, well, this part is A, okay, this part right here, let's change the color here. This part right here is the B, but union, okay, is going to include all of this right here. So instead of this being separated, I would say union includes everything, okay? Well, intersection, okay, on the other hand, let's look at it and go, okay, well, if I have an intersection, okay, symbolized by this little upside down thing, kind of like an upside down N, like an intersection, or like maybe you put a, like maybe it's like the top of a circle or something like that, where it intersects of two or more sets, is all the sets of elements that belong to both sets. Okay? So let's come in here, draw another circle. I've got A, I've got B. Okay, the intersection of these 2 points, without having to color them both in again, is look right here. Notice where those circles kind of cross. That would be the intersection. Where are they all the same? Here, it's including everybody, okay, without repeats. Here, we're just worried about where are they common, okay? And then we're just going to be very intentional about the word or is used to indicate union. So or will be for that symbol, and the word and is used to indicate intersection, okay? That'd be like, where's the intersection of A and B, okay? But if I said A or B, well, that's this or this, okay? But and would be this and this. Where's that? So it's just going to be something you just practice long enough, you just kind of get it, okay? So let's look at this here. Consider the two sets. Okay, this is what a set looks like, usually denoted by a capital letter contained in braces. So I've got the set A of 0, 1, 0, 1, 5, and 7, and the set B of -3, 0, 5, 6, 7. Then determine the sets. Well, I've got A union B, or A or B, and then I've got the intersection of A and B, or A and B. Okay, so here is the intersection. Notice what it is right here. Whenever you have a union, take all the elements from set A and all the elements of set B and put them into one big set named A union B. Just don't have any repeats. Notice how 0 and 0 are the same, so you only got to put 1 0 in there. Let's see here, I've got 5. Yeah, I got 5. Those are going to repeat, so just put 1 5 in there. 7's repeat, so just put 1 7. Okay. Well, how about A and B? A and B, well, that's going to be an intersection. Well, where are they the same? Okay, which ones, and you can almost kind of guess what I'm just about to say, is notice anywhere where you had some repeats in both of them is going to be the area where they're intersecting. Okay, so you're going to have intersected 0, 5, and 7. Okay, let's continue on. Okay, same thing here. Find the union of A and B. Notice you can have unions of anything. Okay, these are sets. This isn't like your natural wholes or anything. You can have sets of anything. Okay, here, notice we got a union, got a little union thing happening here. So that'd be P or Q. Well, that's just listing of everything in here. Okay, everything. Okay, and then here P and Q, once again, just where do they intersect? Where are they the same? Okay, well, the -6's, notice they're the same. The 0's, notice they're the same. They're both in each set. 2, they're both in each set. Okay, straightforward. Let's do this right here. Okay. Now we're going to have to graph these guys. Graph the set of x is less than or equal to 2, and x is greater than or equal to 0, and the word and implies that these values satisfy both the inequalities. Well, notice that x less than 2, well, that's going to be a close, there's a bracket, it's going this direction. X is greater than 0, that's going this direction. Well, whenever we do whenever we graph these, notice this is what we get right here. This is kind of where they intersect. Where are they the same? Okay, that's why they're using and. Okay, where are they intersecting? If this was a huge circle, this is where, okay, this is one set, this is another set, this is where they would intersect. The union of these would literally just be all real numbers. The solution graph shows the intersection of the first two graphs. In other words, the third graph shows the points in common between the first two graphs in this example. This set can be also indicated as x is greater than 0 and x is less than or equal to 2, and that's what they're saying for this one right here. Okay, that's everything they were saying for that one. So let's come back in here and let's do some more. Let's look at example 5. Okay, graph the set. X is less than 5 or x is greater than 5 or x is less than or equal to 4. The word or implies those values of x that satisfy at least one of the inequalities. Okay, notice x is greater than 5. We don't have an equal sign. So if we just graph that, this is the way the graph would look. X is less than or equal to 4. That's going to be a closed bracket. That's going in this direction. Well, notice we have x is less than, or x is greater than 5, or x is less than 4, less than or equal to 4. Okay, notice the reason this is a union is because we have a little gap there. So what we're saying is x can be any number from 4 all the way to negative infinity, or x can get infinitely close to 5 and go to positive infinity. Okay, those are the areas that would actually satisfy that. You can plug in any one of those numbers into that equation and it's going to be true. Okay, but okay, it won't satisfy both of them. This is why it satisfies at least one of the inequalities. So, and that's okay. So let's continue on and let's do an example here. Let's solve a compound inequality here. Solve the compound inequality of this and graph the solution set. Okay, first things first, get rid of the fraction. That's going to be something to just start learning to do now. So let's come in here and we've got 3x minus 5 where 4 is less than 3. Okay, what we're going to do here is I'm going to multiply everything by 4. Both sides here, come in here, 4, 4, and 4. Okay, well notice what's going to happen here. 4 times 0 is still just going to be 0. Okay, keep this, and then notice here, the 4's will cancel, leaving us with 3x minus 5. And here we're going to be with a 12. Now just get the x by itself. So I'm going to add 5 here, add 5, and then I'm also going to add 5 here. So notice we're solving in two directions now. So then I have 5, 3x, and then I've got 17. Okay, so far so good. Start doing the division. Get that x by itself. Okay, well now once I do that, I'll come over here and I've got 5/3. I've got my x, and then I've got my 17/3. Okay, write the solution set using interval notation. Okay, so we're going to have to come in here and go ahead and figure out where these are on a number line. Oops, sorry about that. When we start to solve this, let me make sure that I am sitting correct here. Okay, coming in here and looking at the solution, I always say graph it first. So come in here and notice if we start graphing this, okay, well 3 will go into 5 one time, and that's going to leave us 2/3. So that's going to be basically 1 2/3. So if we come in here, let's do this way. Let's come in here with a 0, 1, 2, 3, 5, 6, and 7 times. Okay, so our first number here, x is greater than. Notice there is not an e or equal sign up in here. Okay, so we're going to have an open bracket. So that's going to be 2 2/3, which is going to put us right about here. Oh, sorry, 1 2/3. Sorry, 1 2/3, right about here, facing the positive direction. Okay. The other part here, well, how many times will 3 go into 17? Well, it'll go in 5 times. Okay, well, because you're saying about 3, 6, 9, 12, 15. That's 5, and that's going to leave us with 2/3. Well, x is going to be less than that. So let's come in here, and we've got 5 2/3, and he's going to be right about there, and he's going to be a closed bracket. And so there is what my x could be, but notice that also gives me my interval notation. And I can write that as 5/3 and 17/3. And that's how we'll go through here and solve these compound inequalities. We'll do a whole bunch more for your Hawks examples, but that's how it's going to be the gist of it.